Hey guys, what's up? My name is Mohit K. Kashyap and I'm back with a new video. This might be probably my last video uh, this sem. So I'm from SVC College of Engineering. So moving on to the next slide. So what is the user datagram protocol? The user datagram protocol is a connectionless, undeniable transport protocol. It does not add anything to the service of IP except for providing process-to-process communication instead of host-to-host communication. UDP is a very simple protocol using a minimum overhead. If a process wants to send a small message and does not care about reliability, it can use UDP. Sending a small message using UDP takes much less interaction between sender and receiver. So what we can see is a diagram of how user data protocol works. So the client is sending request to the server and the server is responding it. So this is how internet works, guys. So moving on to the next slide. So what are the UDP services? So the process to process communication, connectionless services, flow control, error control, checksum, congestion control, encapsulation and decapsulation, queuing, multiplexing and demultiplexing. These are the services provided by the UDP. So as you can look at the figure, so UDP, what are the best practices of UDP? Account for path conditions and transport, implement congestion control, and then bolster bulk transfer applications, streamline low data volume applications, then secure overall network, and then we're moving on to next slide, guys. So what is process-to-process communication? So UDP provides process-to-process communication using socket addresses, a combination of IP addresses and port numbers. So what is connectionless services? So UDP provides a connectionless service. This means that each user datagram sent by UDP is an independent datagram. There is no relationship between the different user datagrams, even if they are coming from the same source process and going to the same destination program. The user datagrams are not numbered. So what is flow control? UDP is a very simple protocol. There is no flow control and hence no video mechanism. The receiver may overflow with incoming messages. The lack of flow control means that the process using UDP should provide for the service if needed. So error control. There is no error control mechanism in UDP except for the checksum. This means that the sender does not know if the message has been lost or duplicated. Even when the receiver detects an error through the checksum, the user datagram is silently discarded. The lack of error control means that the process using UDP should provide for the following needed data. So moving on to the next slide, guys. So in this slide, we're gonna learn about some terms of UDP, which are first one is checksum. UDP checksum calculation includes three solutions: a pseudo header, a UDP header, and the data coming from the application layer. The pseudo header is a part of the header of the IP packet in which the user datagram is to be encapsulated with some fields filled with zeros and the congestion control. Since UDP is a connectionless protocol, it does not provide congestion control. UDP assumes that the packet sent are small and sporadic and cannot create congestion in the network. This assumption may or may not be true today when UDP is used for interactive real-time transfer of audio and video. Then comes encapsulation and decapsulation. To send a message from one process to another, the UDP protocol encapsulates and decapsulates messages. Queuing. We have talked about ports without discussing the actual implementation of them. In UDP, queues are associated with ports. At the client side, when a process starts, it requests a port number from the operating system. Some implementations create both an incoming and an outgoing queue associated with each process. Multiplexing and demultiplexing. In a host running a TCP/IP protocol suite, there is only one UDP, but possibly several processes that services of UDP offer you. To handle this situation, UDP multiplexes and Probably demultiplexes, I guess. So guys, moving on to the next slide. So what are the applications of UDP? UDP is suitable for a process that requires simple request response communication with little concern for flow and error control. It is not usually used for a process such as FTP that needs to send bulk data. UDP is suitable for a process with internal flow and error control mechanisms. For example, the trivial file transfer protocol, which is in short known as TFTP process, includes flow and error control. It can easily use UDP. UDP is a suitable transport protocol for multicasting. Multicasting capability is embedded in the UDP software but not in the TCP software. UDP is used for managing processes such as SNMP. DP is used for some route updating protocols such as routing information protocol. And then UDP is normally used for interactive real-time applications that cannot tolerate uneven delay between sections of received messages. So guys, as you can look at the diagram I have pasted, it mentions all the above applications, which are the straightforward repeat response communication of relatively usual amounts of data. Then multitasking because UDP works with pocket switching. Sorry guys, I'm not able to read that thing because it's too small. And let's mm, moving on to our final slide. So guys, thank you for watching this video. I hope you like it. Bye guys. See you. See you never, I guess. Never ever. Bye guys.